Hey there, class. Mr. Fusky here. Hope you're having a good day so far. We're continuing with Chapter 9. This is 9.5, and it's applying compositions of transformations. A composition is basically like multiple transformations in one. And so we've talked about rotations, we've talked about reflections and translations, and so we're going to be doing basically multiple transformations in one kind of problem, so which is kind of cool. So, no warm-up today, but let's go ahead and get into this. Get my paper here. All right, so a glide reflection. All right, a glide reflection is a translation, followed by a reflection. What? Okay, so you're doing both. You're translating it, you're moving it, shifting it, and then you're also reflecting over a line, okay? Composition of transformations is when two or more transformations, Transformations, okay, are combined to form a single transformation. Let's review some of these rules here, okay? All right, so the coordinate rules for reflections, remember the AB stuff. We want to use XY. I don't really like the AB stuff, so yeah, so for example, if we have, it's going to be XY, okay? So the rule for reflecting over the x-axis is going to be x and opposite of y. Reflecting over the y-axis is going to be opposite of x and y. Reflecting over the line y equals x is going to be y and x. Reflecting over y equals negative x, remember y equals x goes like this, y equals negative x goes like that, 45-degree angle. Okay, that's not great, but it'll get the job done. And it's going to be, the reflection is going to be opposite of y and opposite of x. Okay, double check those. Looks good. All right, what are the rules for rotations? If you guys see you can figure those out, go ahead. Otherwise, we'll fill them out together. All right, 90-degree rotation is going to be the opposite of y and x. 180-degree rotation is going to be opposite of x, opposite of y. And a 270-degree rotation is going to be y and the opposite of x. And so down here, we're going to do y and the opposite of x. We got mixed around here, which is incorrect. All right, so let's do a glide reflection now, okay? So we have this triangle, all right? So why don't we, let's do this here, all right? So we're doing two different things, okay? We are, we're gonna translate using this rule, and then we're going to do, or the translation rule, and then we're gonna do reflection in the x-axis, okay? So let's just kind of go from here. So we're gonna start with our points here. So we have, it goes x comma y goes to, we have a point for A is 2, 1, B is 5, 3, and C is 6, 2. All right, so we're going to start there. Okay. All right, let's actually graph those. Let's go one step at a time here. If we graph these, so 2, 1, we go right 2 up 1. That's A. We have B is 5, 3, right 5 up 3. And we have C, which is right 6 up 2. And that is C. We're going to use a dashed line to show that's where it was. This is where we started. Okay. Now, I'm going to use blue for the intermediate step here, okay, which is the translation. What's the rule for that? Well, it's going to go x minus 8 and y. Okay, so it's going to be A prime, B prime, and C prime. Why don't you guys see if you can figure that out? Go ahead and pause it and see if you can figure out what what's going to be here. Well, this translation is telling us we're going to go which direction on the x. We're going to go left 8 or subtract 8 from the x value, which is going to go 8 to the left. So 2 minus 8 is going to be negative 6. Y is going to stay the same with 1. 5 minus 8 is going to be negative 3. 3 is going to stay the same, so we get negative 3, 3. And 6 minus 8 is going to be negative 2. So we get negative 2, 2. Okay, almost run out of room here, but that's okay. All right, why don't you guys go ahead and graph those? Let's do that. All right, A prime, left 6, up 1. 1, 2, 3, 4, 5, 6, up 1. That's A prime. Okay. B prime is left 3, up 3. B prime. And C prime is left 2, up 2. That's C prime. Still dashed lines because that's where we're not done yet. This is like the intermediate step here. But can you see how it shifted 6 to the left? Yeah, so that's basically the intermediate step. All right, and the last step is going to be a reflection in the x-axis. Well, what's the rule for reflection in the x-axis? That is going to be x comma y. Or sorry, x comma opposite of y, my bad. Okay, so we have, we have A prime, B prime, and C prime. Why don't you guys see if you can figure out this rule here, what's going to happen. Go ahead. All right, well, the x's are going to stay the same. Well, actually, this is A double prime. I goofed up. A double prime, B double prime, C double prime. Okay? Each translation or transformation is going to be another prime. Okay? So, x is going to stay the same. We have negative x, or negative 6, I mean. Negative 3 is going to stay the same, and negative 2 is going to stay the same. Then for y, we're doing the opposite of y. So if y is 1, we're going to have negative 1. If we have y is 3, opposite of 3 is negative 3. And opposite of 2 is going to be negative 2. So if we graph this, we got left 6 down 1. That's A double prime. We have left 3 down 3. That is B double prime. And we have C prime, which is left 2 down 2. And that's C double prime. And you can see this is our final answer here, our final transformation here. You can see it flipped over the x-axis in the middle here. Okay? And that's it. Basically a composition of more than one kind of transformation. Very cool. All right, like we talked about composition theorem. Basically, if you do a composition of isometries, which means that the shape and size are the same, the result is also going to be the same. Okay? Why don't you guys go ahead and do example 2. It's looking for a reflection in the y-axis and a rotation about the origin. Go ahead and give that a try. Okay, so reflection on the x-axis. Let's start with our points here. So we have x comma y. We have C, which is negative 2, 6. And we have D, which is negative 1, 3. Okay. We're doing multiple things here. So C is left 2, up 6. Okay, that's C. We have D, which is left 1, up 3. That is D. Dashed line, that's where it was. It's going to be kind of hard to see what's happening here because it's just like a single line, but we'll do the best we can here. All right, reflection in the in the y-axis, what's that going to be? Well, that's going to be the opposite of x and y. Okay, so we're doing the opposite of x and y. So we have C prime and D prime. So for that, we should have what values? Well, opposite of negative 2 is going to be 2, so we get 2, 6. Opposite of negative 1 is 1, we get 1, 3. And then, last thing we have is 90-degree rotation, which is going to be opposite of y and x. Okay? So, opposite of y and x. So we have C double prime and D double prime. And let's see if we got this here. So, opposite of y, opposite of 2 is negative 2. Opposite of, oh wait, I goofed this up. Let me see here. I goofed something up here. So, I'm looking at this. I'm actually looking at this value right here, right? So opposite of 6 will be negative 6, and then x is going to be 2. It should be negative 6, 2. My bad. Okay? So we're looking at the previous thing. We're not looking back. I was looking back at the beginning here. We don't want to do that. We want to look at the previous thing where we were at, okay? Then opposite of 3 is going to be negative 3, so we get negative 3, and x is 1, so we get negative 3, 1. So for blue, we have 2, 6, right 2, up 6. That's C prime. Then we have D prime, is right 1, up 3. Oops. You can see that that is that's a reflection. And then we have the green one, which is left 6, up 2. And up 2. That's C double prime. And then we have D double prime is left 3, up 1. And that's going to be where it ends up. Okay, sounds good. All right, we got some checkpoints, which are going to be very similar to what we just did. Why don't you guys pause the video if you want some more practice and give those a try. All right, so let's go ahead and do these. We have x comma y. We have A, B, and C. So we have 2, 1, 5, 3, and 6, 2. And these, for blue, it's going to go 5 units down. So 5 units down is going to be, the rule is going to be x and then y minus 5, because we're still going down on the y-axis. So we have a prime, b prime, and c prime. Okay, so if we go down 5, we take away 5 from the y value, we're going to get 2. 1 minus 5 is negative 4. We have 5, negative 2. And we have 6, negative 3. Okay, oops. And then, the last thing we're going to do is then a reflection in the y-axis is going to be the opposite of x and y. So we have a double prime, b double prime, c double prime. Okay. So opposite of x is going to be, opposite of 2 is negative 2. So we got negative 2, negative 4. We have opposite of 5 is negative 5 and negative 2. And then we have c prime, opposite of 6 is negative 6 and negative 6, negative 3. Awesome. All right, number 2. It's similar. We're doing something a little bit different though. But now it wants us to do the rotation first, then the reflection. So let's go ahead and do that. So we have x comma y. We have c and d. C was negative 2, 6. D was negative 1, 3. All right. Okay. And yeah, we'll do this here. I guess we can graph them first. So we got negative 2, 6 is left 2 up 6. That's C. D prime is, or sorry, D is left 1 up 3. That's D. Then we have, so we're doing a rotation first, which is going to be opposite of y, and then x. Okay, so C prime and D prime. So C prime, opposite of y, which is 6, is going to be negative 6. We got negative 6, negative 2. And then we have opposite of 3 is negative 3, so we get negative 3, negative 1. So we go left 6, 2, 3, 4, 5, 6, down 2. Then we have left 3, down 1. These are going to be dashed lines, whoops. Then we have a dashed line here. This is C prime, this is D prime. And then the last thing we have, and then we're doing the reflection, which is going to be the opposite of x, and dang it. We have, let's see here, that's going to be opposite of x and y, okay? So it's going to be C double prime and D double prime. Opposite of x is going to be 6. Negative 2 is going to stay for y, and D double prime is going to be 3. Opposite of, or sorry, y is going to stay the same. We get 3, negative 1. So we go right 6, down 2. That's C double prime. And then we have 3, 1, which is negative 1, which will go right 3, down 1. D double prime. And that is going to be rotation and then a reflection over the axis here. This is a reflection. Okay? Awesome. Sounds good? All right. A couple more things here. Reflections in parallel lines. If you reflect over parallel lines, you get a translation. Okay? So basically the same thing as double the distance between the two parallel lines, right? So if you flip over two parallel lines, the distance they move is equal to 2 times the distance between the parallel lines, okay? And then reflecting over intersecting lines, it's the same thing as a rotation, okay, about point P. All right, so we're actually going to skip example 3. I don't like this example, and we're going to skip this checkpoint right here. So last part's pretty easy, okay? So, let me see if I talked about it up here. Yeah, so basically, if you reflect over intersecting lines, the angle of rotation is going to be 2 times the angle that's reflected by here, 2x basically, okay? So whatever the angle is between the intersecting lines, the rotation after you reflect over them twice is going to be double that angle, right? So if we have this here, we reflect over these intersecting lines, K and M. The angle between them is 80 degrees, so what's the rotation going to be? Well, all it's going to be is going to be double that angle between the lines. What's 2 times 180? Or sorry, 2 times 80 is what? It's 160-degree rotation. Ta-da! That's it. All right, why don't you guys do the checkpoint? It should be super easy. Okay, we're reflecting over intersecting lines. The angle between the intersecting lines is 68, so we're going to double that to get the actual rotation. 2 times 68 equals 136-degree rotation. And that's it. All right, that is all I have for you today. Thank you for watching. Have a great day, and we will talk soon.